Hello, hi. I'm Vladimir. I came from Moldova. And I'm here to talk about web development in D. So I wouldn't actually call myself a web developer, but a few years ago I made this forum software for the D programming language. I wrote it in D, and now everyone expects me to talk about web development. I would say that the foremost expert on web development in D is Zunke Ludwig. He's the author of the Vibe library, which I will be discussing today. Unfortunately, he's not here. I assume he's busy with some very ambitious projects. I actually wanted to do a talk about memory management today. But when I saw the schedule back in February, I saw that there were already two talks about garbage collection. So I think that would be an overflowing heap of memory management data. But at least it will be garbage collected. So for some context, what is web development? And how can it solve your problems? Well, obviously, the first case of web development is development of websites. D is not a markup language, so we'll be talking about dynamic websites with dynamic content. Second is web applications. So whereas previously, about 10 years ago, you would use things like an email client or a word processor offline, or programs alone and install on your computer. Nowadays, you do this in a web browser on the cloud. So that's another application. Third is web services. I'll be talking in depth about REST. So while you could, when you need a program to talk to another program, you could use a binary protocol like Protobuf or Thrift. But there are some advantages in using something over HTTP because it can go through firewalls. It's easier to implement because you can just, it's pretty standardized. It works pretty much like RPC if the language provides an adequate implementation, which we'll show you. And of course, you can't do much web development without databases, so you need some persistence. So I'll cover the topic as well. So of course, the question is, why would you want to use D? I mean, there are already lots of mature and popular frameworks and languages, even languages designed specifically and carefully for web development, such as PHP. Well, I would say this is one reason. These benchmarks are actually conducted by a member of the D community, Mikhail Strashun, aka Dicebot. He asked me to include a very big disclaimer that he ran into some problems when performing these benchmarks. So please take this with a grain of salt. Well, to me, it looks like the winner is visible regardless of any possible problems. I took the liberty of running some benchmarks myself. And these are my results. You can see D in the last column, before and after. This is the Vibe.d framework, which I'll cover. We've compared it with C#, with HTTP listener, Node.js, Java, Erlang. I couldn't get Erlang to work in my benchmarks, but instead, for curiosity, I added PHP. So PHP actually, with Apache 2, performed better than I expected, but it had great scalability problems. I'll cover the topic later. And I also wanted to include Ruby. But I think I did the benchmarks wrong because while everyone got like about above 30,000 requests per second on my test machine, Ruby got about 500. So it can't be that slow, right? So Vibe gets the spotlight of my talk. So what makes Vibe so special? Vibe uses asynchronous I/O, which is what makes other frameworks so fast and scalable. But it uses asynchronous API, which makes code easier to write, as I'll show you in a second. There are some benefits with it. It also has compile time templates, as well as some work in progress on load balancing and zero downtime changes. So one of the big disadvantages of compiled languages over interpreted languages, especially when you have a rapid test cycle. So in PHP, you just edit the PHP file, save it, and refresh your browser. For a compiled program, you have to recompile the program. So this allows you to automatically recompile the programs, the web page, just after you save it. It detects that there was change. It automatically invokes the compiler, and there is zero downtime because there is a load balancer in front. So it's kind of work in progress, but it's there. And finally, Vibe has a few more features, such as REST for web services, SSL support via OpenSSL, and support for 2 NoSQL databases, MongoDB and Redis. So to talk a little about what makes frameworks such as Vibe, Node.js so fast, I'll have to talk a little about history. When web development started to appear, so the first major popular form of dynamic content was CGI. CGI is basically, you send a request to web server, it executes a program, and it prints the result. So it's one program instantiation per request. Obviously, that's not very performant. You have all this overhead of creating a process. The process has to load its data. Even if it's cached, there's still lots of overhead. So CGI was replaced by fast CGI, as well as Apache models like mod.php. And while that solved the problem of loading the program, there's still the problem that, well, Apache processes each request in its own thread or process. Actually, you kind of have to use processes in real life because PHP, well, they don't recommend running anything in threads. They don't recommend running multiple PHP programs in the same thread. I think PHP is thread safe by itself, but some extensions aren't. About this time, the C10K problem was formulated. So this is a problem, a challenge to developers of web servers to support 10,000 concurrent connections. You just can't get that far with threads or processes because the overhead of each process or thread, when we're talking about native processes or threads as are implemented by the operating system, is pretty big. And it just doesn't scale. So about that time, web services, Nginx and Lite started to appear. These use an asynchronous programming model. So everything runs in one thread. There can be multiple threads for extra balancing. And it uses events to get events notifications from incoming data, accepted connections, and unblocked sockets when we have something to write to the socket. This allows them to scale very well. So for example, I've made this chart. I hope it illustrates the purpose. If we have one thread per connection on the left, and asynchronous, we have one task, which is the event loop. It dispatches the events to the relevant handlers of these events. So whenever a connection is accepted, for example, you'll want to send some data, then wait for the socket to be writable again, or you want to read some data, so you want to wait for the socket to be readable. So register an event, and then you exit the procedure, and you just wait for a callback, or it depends on the programming model, as I'll show you. So 2 major programming models have emerged. The first is desynchronous. This is something like what you'd use in PHP. You call functions such as query the database or read a file, or connect to a socket to an address. And you just wait until it's done. And the synchronous model, which is mostly popularized by Node.js, is that you start something, and you give it a delegate. So function execution continues after the last statement, after the last line. But that delegate will be called when the condition has been fulfilled. So there's some advantages and disadvantages to each model, but as I'll show you, this is pretty much synonymous code. On the left, it uses the synchronous model. So here we connect to a database. We just invoke various calls. And the data will be ready when the statement is finished. We can just use it immediately. And with the asynchronous model, it's a little more problematic because we have to register a callback for each event. And if you want to handle an event after an event was handled, which was registered after an event was handled, you got these levels of nesting. There's also the problem of error handling. So with the synchronous model, exceptions take care of everything. You can use your favorite language's exception handling mechanisms. For example, in D, you can use scope exit or scope failure for error recovery. You can sort of implement transactions that way if we're talking about cross-database transactions or non-database transactions. And with the asynchronous model, you notice that each function gets an error parameter. This parameter exists because the framework can't throw for you. The reason it can't throw for you is because if you look at the stack trace, you won't see your code in there. It will just have framework code because the stack trace, the top of the stack trace will be the event loop. The event loop will invoke your delegate, but if it will throw before invoking your delegate, you won't see any context. So that's why it's customary to just handle errors whenever you in the start of your callback. I think this is valid code. On the right, this is an adapted Node.js example. On the left is Vibe with the main function stripped off. So what Vibe gains is that it achieves the performance of asynchronous code with the API with synchronous code. The reason why that's exciting, because with synchronous code, usually, while you perform a blocking call, such as connecting to a database or waiting for data, the thread remains idle, but it consumes resources. So it consumes stack, it consumes whatever the overhead of the OS threads and processes are. If you have 10,000 simultaneous connections, that overhead is pretty large and it just doesn't scale. So Vibe uses fibers to achieve this task. Fibers are they're related to coroutines in that you can pause a fiber transparently, and the event loop will resume it when any registered event is received. So we can use this code here instead of blocking on, for example, on connect MongoDB. What really happens is that Vibe registers an event handler for when the connection is established, and it suspends the current fiber. It then continues the event loop and wakes up any other fibers which have pending events, so it just idles. And when the event loop notifies that a connection has been established, then it resumes this fiber and execution continues. So to get back here, you can think of each lines with the orange rectangles in the right part as fibers. And the red ones is the event loop, which simply dispatches events to each fiber. It wakes up a fiber, the fiber runs, and it finishes. So you'll notice that inside the thread, of course, only one fiber runs at a time. That means it's mostly thread safe, assuming you don't share the data between threads. Well, you could say it's fiber safe instead of thread safe. So I'd like to say about Vibe.d in a few words, how you can get started writing web applications using Vibe. Vibe is integrated with a package manager, which is also written by Zunke Ludwig. It's called dub. You can, similar to Rake, you can just write dub init and your application name. It will create a directory structure. On the right is something with an example of a web directory, although it will only create a package JSON and an apt file by default. The other folders will be empty. You can place your content in them. So this is an example of a package JSON file. Since Vibe relies on a package manager, you can specify dependencies on other packages, which will allow automatically installing those dependencies when you set up your project, when someone else uses your project. And here's the example source code. On the left, you have the D source code. And on the right is the templates, the Diet template language. So notice that in the left part, there is no main function. This is because Vibe has its own main function. Of course, you can opt out if you want. By default, Vibe handles command line arguments. It has a logging mechanism, so you can specify logging verbosity using the command line. You can specify the listening port if you like. All this exists already in the Vibe framework. This example overrides the listening port, and it specifies a URL router, which handles the index request. And in the request handler, it renders the Diet template with the parameters with the context of the HTTP request. So there are two Diet templates. You'll notice that the layout.dt file specifies the general layout. There is a body block here, which is substituted by whatever you like. For example, you would have different web pages which use the same layout. And the index.dt file is the block body for the index page. So what's interesting about diet templates is that their compile time. That means when you compile your Vibe application, during compiling it, using these compile time function execution and the capability to read files off the disk, it will transform the diet template code into D code, which will end up as machine code. So it will be optimized as fast as a JIT, basically. The diet templates are relatively feature-rich. You have the usual insertions. You can place even D code if you start the line with the dash. You can create loops like this. You can iterate over arrays or ranges, pretty much anything. This diet template language is actually based on Node.js's Jade template language. It does have many similarities. So let's talk about web services. I already mentioned some advantages of using HTTP instead of sockets. Sorry, am I going too fast? So REST is basically an architecture for designing network applications. It has some ideas which define it. The first is that it's client-server, so there's a client taking server taking requests and a client performing them. It's stateless. That means that each request doesn't have context. So, for example, you want to get if you issue a request now or after a few other requests, it will not be interpreted differently. It's cacheable. That means you can cache the results. HTTP has some caching mechanism which already provide the tools to do this. Well, the last two is that they're a layered system and using a uniform interface. That means you can they're nested so that you can place different sort of you can organize your resources according to a directory structure. Vibe provides the mechanisms to implement a REST client and server. So Vibe makes use of the user-defined attributes to allow you to specify a custom path. But what's interesting about this is that it uses D interfaces to implicitly bind them to HTTP paths. So for example, if you write a getIndex method, index will be interpreted as meaning just the root of the web server request. If you implement a data property, you can use get and put HTTP requests to read and write it. And well, yeah, you can use parameters, which will get taken off from the post request body or from the query string. And of course, you can customize the path using user-defined attributes. This is what it looks to create a REST client. So you just write the interface, and you just set fields, query fields, call functions. It works kind of like a native object, except it's blocking. And of course, it uses Vibe's fibers. So it's blocking, but it's synchronous API, but asynchronous performance. You can, of course, also implement REST service. So you basically implement a class which implements the interface. So you provide function bodies for all the functions in the interface. You create to create a service, just register it in the URL router, and you call register REST interface, specify the interface, and create the example and specify the path. It's really easy, and I think it provides a very interesting alternative to the classical methods of sending data, unpacking it, deserializing it, etc. So another thing I'd like to show you is that notice how some methods return ints. Vibe actually implicitly converts, serializes and deserializes everything to JSON. So you can have a user type, for example, a structure, and it will automatically serialize or deserialize it before any request. It works with structures, I think classes as well, arrays, associative arrays, because JavaScript provides objects. So that's all I wanted to say about. A few more things about Vibe. Well, I already mentioned that it supports SSL via SSL. It has two databases. It supports two databases, MongoDB and Redis. Vibe can run as root if you like. It will automatically change the current user after creating the listening port, so you can use it as a full-fledged web server. If you don't like to do it, of course, you can put it in front of a reverse proxy like Nginx. And I've mentioned DAB. It already has a registry, which you can find on registry.vibed.org. There are already some very interesting projects there. For example, there's Socket.io. You may know it from Node. This is an implementation for Vibe. It allows you it provides an easy API which allows your client, your JavaScript code, to communicate with your server. And it automatically works over a number of transports. For example, it uses WebSockets if those are available. If not, it will use something like Comet, long polling, things like that. There's SES Vibe, which is implementation of SES, which is the CSS extension. Just add some syntax sugar to CSS as well. It allows you to write expressions such as darken this color by 90%. It allows you to write SES files, and Vibe will transparently compile them to CSS and serve them as CSS. Vibe.d, I've mentioned, this is the Vibe's component for load balancing. It's a little work in progress. There's a MySQL driver, if you like SQL. There's a MVC framework. So Vibe by default just gives you the basic tools such as diet templates. But if you like a more classical, more full-fledged MVC framework, there's Zeal, which is on top of Vibe. And there are several of many other interesting projects, so check it out. So how many of you have heard about the application Cool Reader for Android? No one? No one reads books? Oh, okay. So Vadim Lopatin, the author, is actually interested in D, and he created a database library. He ported it follows the principles of Hibernate from Java. You basically define the structure of your database as user types, classes, and you can use user-defined attributes to specify things like whether this class is embedded, so it will exist in the same row as in the same table as other classes which reference it. You can specify the relationships. For example, if it's many-to-many, you have to specify that explicitly. That will create a new table which specifies IDs which IDs in the first table correlate to which IDs in the other table. Otherwise, it's assumed to be many-to-one, so it's just an index in one of the tables. The API is pretty much just like in Java, as I understood it. After you define the types, you just set the fields, you instantiate the classes, you set the fields, and you call save to save them to the database. You can query them using the HQL query language, if I remember correctly. It's a variant of SQL. And I'd like to mention a few more projects which relate to web development. I've practically shown you the spotlight, so projects which I consider to be most interesting. But that doesn't mean that there aren't other projects which might be interesting to you. So if you just want CGI, and maybe you don't want to listen on port 80, or you don't want to listen on any port, you just want to plug in into an existing web server which supports CGI. Maybe you don't care about insane performance. So Adam Ruppy has written a library which provides CGI. It has a few other interesting tools to manipulate HTML. The forum software, which are written for forum.lang.org, uses my own library. I thought I'd mention it, but really there's not much reason to look into it. I'm actually thinking of ditching it away and switching to Vibe. I actually really wanted to do this for this talk, but because the forum software is written in a different programming model, it uses asynchronous API like Node, but I use classes because the code is so ancient. I ran into some problems importing it, so I hope to do that at some point, though. Zonky has actually been very responsive to my input when I presented my problems to him. He was very open about even changing some core concepts in how Vibe handles connection ownership. So right now with Vibe, well, before when we talked, you kind of have to pass ownership between mutexes because between fibers. One fiber implicitly owns its connection, which is a little problem because when you want to receive data from one connection, want to write it to another, well, the other connection is owned by another fiber. But he's been very responsive to my input, and he's actually considering completely ditching that in favor of just making the code very simple. Although this explicit ownership does provide an additional degree of safety, because what happens if you write to the same connection from two fibers? If you have interleaving data, the data might get interleaved if you have a lot of data, because one fiber might get woken up, it'll write a segment, another fiber will get woken up, and another segment will get junk. Database access, package management. So Jakob Karlborg has also written a package manager. It's called Orbit, but it hasn't really taken off for some reason. I guess because Vibe came in and just promoted its own package manager, but it's also an interesting project. I think it has some concepts differently from Dub. As for database access, so Vadim Lopatin actually wrote part of his Hibernate.d project also contains a sub package called DDBC. But before that, there was another DDBC project made by Mandeep Singh Brar, I think that's how you pronounce it. So if you don't find something in Hibernate.d, for example, if you need a Postgres driver, I think that's not present in Hibernate.d yet, but it's present in DDBC. And there was another template engine which was announced not too long before. Well, Mustache isn't actually specific for D. It's just a port of the Mustache engine to D by Masahiro Nagakawa. So let's talk about JavaScript. Yes?
Masahiro keeps doing himself, so you should know he's here. Get up.
Oh, hi.
This is he. You didn't know. Okay, great. Give him a hand. Thank you.
JavaScript. So the client in web applications is obviously the web browser. And the dominant language in web browsers is JavaScript. There was Visual VBasic. I'm glad it died. There's Dart. I don't think it has taken off. So often it's really useful to run the same code on the client and on the server. For example, one of the most common examples is form validation. Maybe you have some complicated validation logic, and you don't want to issue AJAX requests because maybe you want to make the experience to be instant without any delay. Or maybe you're writing a video game. So because of the latency issues, you really need to run the logic in the browser. Otherwise, there's going to be lots of screen lag. But the server also needs to verify the data that's sent from the client. And if you just try to implement your logic in one language and then the client in another language, eventually there will be differences and it might get out of sync and it's a mess. But what can you do to resolve this problem? There are a few ways to go around it. The first is to run JavaScript in D. There's two projects. First is DMD script, which is written by Walder. I believe it's actually the fastest JavaScript implementation that doesn't use a cheat. Is that correct, Walter?
Well, it was at the time I wrote it.
Right.
It's also available on GitHub, by the way.
No, Walter says that it's faster at the time he wrote it. But I think by the time he wrote it, the JIT and JavaScript compiler started to appear. And so DMT script is not JIT, but Higgs is, and Maxime will be presenting that later today. I'm really looking forward to the talk. And of course, and for those who are interested in experimenting things, there are a few experimental projects. So Adam Rupi has hacked the DMD compiler, the official decompiler, to instead of emitting machine code, it emits JavaScript, which I think is really interesting. And you know ABBA, anyone here knows ABBA games? Games like Tourist Trooper or Konami Fighters? Those games are actually written in a really long time ago, in a really old version of these, like 0.7 something. But it looks like he's interested in D again because he picked it up and used LLVM, so LDC, together with mscripten, which is LLDC's backend to generate JavaScript code to emit Async.js. Async.js is a subset of JavaScript which allows browsers to run code very efficiently. It's a very strict subset which maps almost directly to machine code. This allows it to run really quickly if browsers can take advantage of it. So naturally, a compiled language can take advantage of this the most. So ABBA has actually got put together all these projects and got it to work. It's a proof of concept, but it's really interesting, and you may want to give it your attention. And finally, I think Nick Sobolowski wrote a translator from Hexy to D. So Hexy is a project, it's a programming language whose purpose is not to compile to intermediary code, something proprietary, or to machine code. Its purpose is to translate itself to other languages. So it translates to PHP, to JavaScript, to ActionScript, to a lot of languages. And Nick actually got it to emit decode. So you can write your logic, for example, in Hexy, and you can then translate it to decode, include it in your D program, and then translate it to JavaScript and include it with your JavaScript source code. Well, that went a lot quicker than I expected. I'm still barely half the time, am I? So what's for the future? Well, obviously, Vibe is quickly evolving. I've talked with, while I was preparing this talk, I've talked a lot with Zunke about what we can do with Vibe. I was trying to port dfeed and was thinking maybe it could be used as an example of what else is needed in Vibe, because dfeed is actually not just a forum software, it contains a lot of other things. It's actually not even forum software, because it uses the digital mouse NNTP server, so the Usenet server, as a source of messages. And any messages are actually sent to that news group. So that it's done this way so that users of Usenet clients, such as Thunderbird, can still access it using that client if they're used to this kind of workflow. But at the same time, it uses local SQLite database for caching. So it also has things like an IRC client. It announces things on IRC whenever some new thread is posted. It also queries a few blogs via RSS and also sends them off to IRC. It's even a mailing list client, so it accepts mailing list messages which are proxied via socket. And all of this, I couldn't really quite get it to work on Vibe because I had things like for the NNTP. For example, when I download a lot of the messages when the server is starting, I used throttling and a queue of messages. For example, I sent 5 requests, and when the reply for the first request came, I sent the 6th request. So it's kind of like pipelining. And I couldn't figure out how to do this with the Fiber synchronous model. But I've discussed it with Zunke, and I think we're coming to a solution. So I think Zunke has already pushed it to Vibe. I haven't really gotten around to it yet, because I was thinking about, of course, the biggest question is, how can we get this into D? Getting something like Vibe into D, I think, would create some serious competition for other languages and frameworks, such as Node, because of all of these advantages. It's really fast, as you can see. Well, my benchmarks are, I really advise you to run your own benchmarks, so big disclaimer here. I can, if you like, I post on the forum, and I'll get back to you, and I'll post the source code of my benchmarks. So I've written sort of a draft of what we can do. The idea is to allow multiple event libraries, such as libevent. We probably don't want to support each operating system individually, because each operating systems like FreeBSD, OpenBSD, Linux, Windows, they can use different APIs for efficient asynchronous programming. So if you're interested, check out that link and send me your comments. I'd love to hear them. So I guess that's all. That was a lot, very fast. I'll take your answer. I'd like to thank Zunke, and of course Mikhail Strashun, who wrote the initial benchmarks which I've showed you. Any questions?
Right. I should add a few words. You should know this is Vladimir's first public talk, and a lot better than my first public talk. This was awesome. And from what I can tell, he was like 13 years old, or you know. So we have quite a few minutes for questions and comments about everything he talked about. So have at it.
How does your forum software fit into this?
Well, I wrote the forum software before I even knew that Vibe. Well, Vibe was started before it was announced. Vibe was announced about 1 year ago, I believe. And the forum software was, I posted about it more than like a year and a half. I think it was last, well, November 2011, something like that. The forum software uses a asynchronous programming model, kind of like Node, but since it uses the framework which I've shown before, the AE library, it's an old library which I started writing back when in D1. What I'd really like to do is get my forum software and port it to Vibe. And in the meantime, also improve Vibe so that it has everything needed to allow the forum software to work. That, or maybe the alternative is getting everything into D as well. So maybe we could create a baseline specification for what is required for Vibe for the forum software. With your feedback, we can get more requirements, what exactly is needed. The advantage of getting it into D is that libraries and frameworks like Vibe can coexist within the same framework. And this would allow some competition. So you probably remember the problems with Phobos and Tango. They couldn't coexist because each one had its own runtime. It was incompatible. So it would be really nice if you could avoid that and have the basic things, the event loop, into D proper. And maybe we could even generalize it not just to web programming, not just to network programming, but event loops in general. For example, in Windows, oh, sorry, I got carried away. Should I continue?
Yes. It's very interesting what you're saying. Keep going.
For example, in Windows, the event loop is basically, oh, you get message, translate message, dispatch message. But this event loop also handles network events if you use WSA async select. You register a notification via Windows messages. So this Windows event loop intrinsically doesn't know anything about the network. But I thought maybe we could design something so that we could have the Windows event loop, and it could expose different interfaces, or we could allow interfaces to plug into it and expand it. So that way you have the Windows event loop core, and if you use a network library, it will plug into it and register, oh, I want notifications for network events, and stuff like that. You could also use it for just not network events. Yes, please.
So a question about the Vibe internals. I don't know if you're the right person to ask. I guess you are now. how does it interact with the low-level hardware? Like you say there's an event loop.
Yes.
Is it in a single thread, or can it be
Vibe
dispatched by the actual driver?
Vibe can run Vibe in multiple threads. That means that each thread will have its own event loop. So on the right, you can see this illustration is probably no good, but each outer box is a thread, and in each thread there are multiple fibers. So you don't want to communicate between these two threads because you can get synchronization issues. You should act like these two are separate processes, and in front of them there's a load balancer. Vibe already does all this. So the question is also how it interacts with the hardware. Vibe uses existing abstract event loop libraries like libevent, libev, but on Windows it also can use the native stuff, like, well, WSA async select basically.
Yes,
Vibe also allows not just networking, but also asynchronous file access. So it registers, uses non-blocking calls to read files off the disk, and there's also stuff for asynchronous DNS resolution. As you know, that's been a problem for a while because DNS resolution was for a long time it was synchronous, so the current thread was blocking until you got timeout from the DNS server or something, and a lot more features like that.
In particular, for example, on Windows, when a packet comes in, is actually the driver, the network driver, is the first to know. And the OS has the ability to actually call your code immediately when that happens, instead of queuing on the I/O completion port and then waiting for your thread to kick in and then dispatch another message. So one of the things they try to do with .NET is really have async await, create a callback on the I/O completion port directly, and save another thread switch to your user mode thread.
Vibe doesn't currently support I/O completion ports. I actually thought about I/O completion ports and how they fit with D. I/O completion ports select an arbitrary thread from the idle thread pool to handle your request. But here's the thing that D relies a lot on TLS, on thread local storage. Basically, any global or static variables by default are TLS. So there's this problem that if you start waiting for an event, and when you wake up, you could wake up in a completely different thread, and it's like, where's my data? I just saved a variable in a static value, in a static variable, and a global variable, and it's not there because I got woken up in another thread. So it's an interesting problem. I'm not sure how we would approach this in D. Yes, please?
What operating systems is this for?
Oh, I think it runs on Windows, Linux, and FreeBSD, I believe.
So I'm not sure I understood something very basic. Am I limited to using Vibe APIs? Or if not, what happens if I use an API that ultimately invokes a blocking system call? Will my thread be blocked and the other Vibers not get a chance to be executed until that is completed?
Yes,
Thanks.
You should avoid blocking calls. So that's one difference between the fiber model and the I/O completion ports. I/O completion ports will, when you issue a blocking call, they will immediately resume another thread which is waiting if there's an event pending. But here you have to use Vibe's API, which is also synchronous, but it is asynchronous under the hood. So if you want to read the file asynchronously, you don't use std file read, you use Vibe's code to read the file.
So maybe I can just quickly add to that, because I actually worked with Sanki on that. Many C libraries, so the problem generally is when you have such a special I/O system that you can't use any C libraries around, right? Because all the libraries need to use your transports. But actually it's the case that many C libraries like OpenSSL actually allow you to use your custom transports. And because Vibe actually offers a blocking API, if you're not by accident screwing up any internal state. This is to say, if the C library is re-entrance, you can actually context switch. You can register a custom transport for your C library. There are often like callbacks for that. Then context switch away from within the C library, and you can get a surprisingly big share of code to work this way. So I mean, it's to me, when I first looked at Vibe, and I did something similar before Vibe was around for like my Google Summer of Code project, which was Thrift. It looked like it would be a total like no-go to use any existing C code, but actually it turned out that quite a big part of it is actually adaptable this way.
So do you think D library in general, like D runtime and Phobos, should start to use Fiber and Yield on I/O in general, like Vibe.d does, or is it something that we should reserve for an external library?
I think we can create an API which uses the same form as it uses the synchronous model, but the user can select whether they want to use an event loop or just use blocking calls, because the function calls are the same. For example, if currently if you want to sleep for 5 seconds, you call thread.sleep and specify 5 seconds as the parameter. But we could create, there could be a global object which is like an interface which points to an implementation. The class would be the implementation of either a classic blocking API, which would call thread.sleep for 5 seconds, or if the user specified that they want an event loop, and they started one, for example, in the main function, that would override the default implementation, and it would go through the event loop. It would register a timer event for 5 seconds. In my proposal, which I probably should have discussed more in depth, I've mentioned that we could create, well, the disadvantage of fibers is that they still use lots of virtual memory. Each fiber needs enough virtual memory to hold a stack. So on 64 bits, this is not a problem. The problem comes on 32 bits because address space is so limited. You can create 10,000 fibers, well, maybe you can create a very large number of fibers with the default stack size, so you have to sacrifice somewhere on 32 bits. Of course, most servers today are 64 bits, so that's not a problem. So to reiterate, this is not a problem with physical memory, this is a problem with virtual memory, just address space. So I think because of this overhead, I think that what we could do is underneath use an asynchronous API and implement asynchronous API using fibers on top of the asynchronous API. So the fiber layer would register event handlers as delegates, and they would just wake up the corresponding fibers in user code. I hope that answers the question.
So I'm kind of intrigued by the dub build system. Is that intended as a replacement for DSSS or what?
Oh, DSSS. I haven't heard that in a while.
It seems to have a lot of the same features, or at least intents.
I'm not sure if DSSS supported downloading dependencies. I don't think it did. Did it?
I think so.
It did? I don't think so. DSSS did have a configuration file which allowed you to specify things like which libraries you want to link in, I mean static libraries. The package.json file, which dub uses, also has that. But it also allows, like package managers in the modern languages like Ruby and Node, the dependencies is just hit, type whatever command, it'll install everything and maybe even start your project. So dub is like that. It's not so much as a replacement for a build system, it's more of a package manager on top of the existing tools. Dub actually has 2 build modes. One is to invoke DMD directly. It just takes the collection of D files in your source directory and it passes them to DMD. Or you can use RDMD, which is already an existing build system for D. It's packaged together with the compiler. It's there, and if you like to use it, you can use it. It can take advantage of some features such as caching and stuff. It won't include models which are not used. That's it, basically.
All right. Thanks, Vladimir. One last question. All right, Ovidiu.
Is Hibernate.d fiber aware? Is it written?
Yes, it's based on Vibe, as far as I know.
Nice.
All right, one more hand for Vladimir.
Sorry for screwing it up.
Ladies and gentlemen, at this time we'll take a 10-minute break. Thank you.
Good job.